Hello, everyone, and welcome to this fourth installment of the new National Climate Assessment Roundtable series. My name is Melanie Wood. I want to let you know that today's roundtable is being live captioned by the kind assistance of Fed Relay. If you'd like to take advantage of captioning, just use the link we will share in the chat box now. This roundtable series is intended to deliver area-specific information to the units of the National Park System within each of 10 National Climate Assessment regions. The roundtables are opportunities to discuss and ask questions about the latest findings of the 2018 assessment, and we encourage your participation today. Today's roundtable will focus squarely on parks in the southeast region of the assessment. If you happen to be calling in from a park outside this area, we still very much welcome your participation. Subsequent installments will focus on additional regions throughout the year. Recordings of past events and a full schedule of upcoming roundtables can be found using the link we are posting in the chat box now. As part of today's call, we'll be hearing shortly from Adam Terando on findings, impacts, and actions from the 4th National Climate Assessment, followed by an open question and answer session. We'll also have a panel discussion featuring several invited guests from parks in the Southeast region, followed by a second question and answer session. Oh, oops, I need to be advancing. Hang on, sorry. We'll conclude the broadcast promptly at 2:30 Eastern Time. Okay. I will be one of two facilitators on today's roundtable. I would also like to introduce my colleague, Matt Hawley, who will be helping me manage our technology today. And speaking of the tech, a few quick words about it before we begin. All of the functionality on the webinar interface is accessed through this tiny toolbar. If the panels are not already visible, you can access them by clicking on the right arrow button at the top of the toolbar. Be aware that your panels may minimize periodically by default, but you can set them to remain open by clicking along the view along the top menu and deselecting the auto hide option. The radio buttons in your audio panel show how you are currently connected to the webinar. For best quality, we highly recommend that you dial in via phone rather than using computer audio. If you're currently connected via computer audio, you are welcome to switch over to phone audio at this time by selecting the phone radio button. We have quite a few participants on the line today, so all participants are muted to keep background noise in check. We will, however, have a couple of dedicated question and answer periods during this roundtable. Again, these roundtables are golden opportunities to ask questions of our invited experts and practitioners relative to your park and challenges you face. So we really welcome you to bring your voice into the room, and there are two ways to do so today. If you have a question you'd like to ask during our Q&A sessions, simply find the Raise Your Hand icon on the webinar interface, and we will unmute you by one to ask your questions. And just so everyone gets familiar with that functionality, I'd like to ask everyone that can hear my voice to raise their hand now.
Melanie, the hands are coming up. I'm seeing them, green hands everywhere. These are our webinar experts that we have today.
Thank you. In addition to our dedicated question and answer periods, we welcome and encourage you to submit questions throughout any portion of this broadcast. To do so, just enter your text into the questions panel as you see here. Matt and I will monitor for incoming questions and pose them to our speakers and panelists at our first opportunity. Additionally, should you have any difficulty with the technology today, you can use the same questions panel to let Matt and I know. Finally, be aware that this live session is being recorded for your future reference and sharing online. So with that, let's get started. At this time, I'd like to invite Kat Hawkins-Hoffman, Chief of the National Park Service Climate Change Response Program, to say a few words to kick off this roundtable. Kat?
Yeah, thank you, Melanie. So I think the staff have an objective for me on this, which is to not take much time. And my objective is to thank our speaker, Adam, and the panelists for coming on board to talk about the findings of the National Climate Assessment in the Southeast region, and then within that area, what Parks experience is and how you're responding. So I very much thank Adam and our other panelists Dan, Barbara, Jeff West, very much appreciated. And I have personal experience at Cape Lookout, so Jeff, your presentation will be of much interest. But the main thing I also want to do is emphasize to those of you that are on the webinar that this is a really great opportunity for you to ask questions. And as Melanie said, we encourage that. One of the main reasons that we wanted to set this up is to be as interactive as possible. So please do make use of that chat function. Even if we're not able to get to all of the questions in the discussion on the webinar, we'll endeavor to respond to as many as we can. So you've got an author of that Southeast chapter here with us, and please take advantage of that and submit questions. So I'll turn it back to you, Melanie, and hopefully I didn't take too much time.
No, thank you so much, Kat. Okay, I am very happy and excited to welcome Adam Terando as our featured speaker today. Adam is a research ecologist with the U.S. Geological Survey at the Southeast Climate Adaptation Science Center, located at North Carolina State University. His research focuses on the risks posed by climate and land use change to ecosystems and the complex human-environment relationships that drive these processes. This includes understanding and predicting climatically induced changes to extreme wildfires in the Southeast U.S., developing methods to quantify the information value of climate models for use in adaptive management problems, simulating urban growth and land use pattern change in the Southeast, and developing ultra-high resolution climate projections for the U.S. Caribbean to support the creation of robust conservation strategies for at-risk species. Adam recently served as the federal coordinating lead author and co-author for the U.S. National Climate Assessment's Southeast and Caribbean chapters, which provide a comprehensive synthesis of climate change impacts, risks, and adaptation choices facing the nation. So take it away, Adam.
Great, thanks, Melanie. And let me go ahead and share my screen here. And my apologies if my webcam isn't working. We'll just make do with my voice. So we'll just use that instrument right now. So
yeah, Adam. Oh, there we go. We just got you now. Thank you.
Okay, great. So you can see my screen?
Yes, sir.
Okay, great. All right. Well, thanks again for inviting me. It's really a pleasure to be speaking with you all, and it's a really important topic, and so I'm glad to have the opportunity to do this. So so we're going to talk today about results from the National Climate Assessment, and really results from the 2 volumes of the most recent report that came out. So the U.S. Global Change Research Program, you see my nose, established several decades ago, and as mandated in the Global Change Research Act, their reports are to be produced to Congress by the U.S. government every 4 years. And so this is the 4th one, the 4th National Climate Assessment, which we've split up into 2 volumes. Volume 1, which is the Climate Science Special Report, which is basically the physical science of climate change in the U.S. And that came out in 2017. On a lot of slides, if I'm citing figures from that report, it'll say something like CSSR. So that's Climate Science Special Report. And then volume 2, which is where I was the lead author on the Southeast chapter and then a co-author on the Caribbean chapter. That's more of the impacts, risks, and types of adaptations that are described and cataloged in volume 2. And that was released just this past November. So just to, at the top, show you the chapter that I worked on, which is the Southeast chapter. I'm not going to go into detail on this now because we'll talk about it later. But we have these 4 key messages related to urban infrastructure and health risks. And we organize these by key messages. So we had flood risks, increasing flood risks in coastal and low-lying regions. Key message 3 related to how natural ecosystems are being transformed and will be transformed in the future. And then key message 4, for the Southeast related to economic and health risks for rural communities. So we'll get into that later on in the presentation, but just to give you a little heads up about what the things that we focused on were in the chapter. So first, and apologies if this is review or, ad nauseum review for you all by now, but I think it's good just to remind ourselves why we're all here. So the greenhouse effect, you probably are familiar in some type of cartoon like this where you get solar radiation coming in, some of it gets trapped in the atmosphere or near the Earth's surface by carbon dioxide, and then as you add more carbon dioxide, that heats up the Earth, right? We can go into a little bit more detail, and I like to get down to the nitty-gritty in just a couple slides about what that actually means, what the physical process of that is. And to do that, we have to think about what light energy actually is. Like, what do we mean by energy and radiation when we talk about those two things? Well, all light energy comes in packets, little packets of energy that we call photons. These are these little subatomic particles, is one of those fundamental elements of the universe. And photons radiate through the universe as electromagnetic waves. So they have this weird duality. This is where you get into quantum physics, this dual nature of both being like particles, but also being waves. And so the more energetic the photons as they're radiating through space, the shorter the wavelength. And why that's important really is just because most energy from the sun that we receive from the sun is in what we call the visible portion of the electromagnetic spectrum. And those wavelengths tend to be shorter than, say, the wavelengths that are then emitted from the Earth's surface. So the Earth is going to absorb that radiation that heats the Earth up as we absorb that energy. But the energy that then gets re-radiated back out to space is at a longer wavelength, okay? So why is that important? Well, carbon dioxide, the amount of carbon dioxide in the atmosphere, that actually allows energy from the sun, those shorter wavelengths of energy, those photons, to pass through relatively undisturbed, at least in terms of undisturbed by carbon dioxide molecules. So as it reaches the Earth's surface, temperature goes up. But then Earth's returning energy, again at those longer wavelengths, because Earth has less energy than the sun, so that means those wavelengths are going to be longer and less energetic, those wavelengths happen to be able to excite carbon dioxide molecules. So they interact with those molecules. And that means it's harder for those photons to escape back out to space, particularly as you add more and more carbon dioxide to the atmosphere. And so what does that mean? Well, we burn a lot of fossilized plants right now. Our society is digging up a lot of that stored carbon that's been stored in the ground for millions of years and hundreds of millions of years. And we use that in power plants and for fuel and cars, and it's been that stored energy has been down there for a really long time. And so we can see then what the result of that been is in terms of the rate of CO2 that we're adding to the atmosphere. So this is an animation from NOAA, and this is showing measurements of carbon dioxide going through time. And this is showing on the left here is different observations of carbon dioxide across the Earth. So this is showing latitude here, it's going from the South Pole to the North Pole. And then this is showing the time series from one particular measurement. This is in Hawaii, sort of the canonical measurement at Mauna Loa Observatory. And so you see how we're going up and up and up. And now we're going back in time. And so now we're going to start to use Parksi records of carbon dioxide. So things like from corals and pollen records, and as we go further and further back into time, you see we still have this is where we are right now. Now we're going to go further back in time. So now we're looking at 15,000 years, 25,000 years, 40,000 years into the past. Now we're using ice core records to get this sort of information. 150,000 years, and you see the ice age is showing up. And so you can see where we are here compared to the natural cycles of CO2 in the atmosphere, if you will, and really how this sort of instantaneous amount of carbon that we've added into the atmosphere, how that compares to the natural or non-anthropogenic or human-caused perturbation of the carbon cycle. So this is what happens when you dig up gigatons of carbon and release it into the atmosphere every year. You get this instantaneous pulse of carbon that then the Earth's energy balance is going to react to in some way. You cannot put this much carbon into the atmosphere without it having an effect on the Earth's energy balance and therefore the climate system. And so there's three big changes then that we think about as the Earth warms in response to this increased amount of carbon in the atmosphere. One, it gets warmer. Two, it rains harder. And three, the seas rise. Now, of course, there's other effects as well, but I think it's useful to think about putting them in sort of these three big buckets in terms of then the major impacts that we often think about. So going to a little detail more about these. So it gets warmer. This is the most obvious one and the one that we think about. Here's showing the observed changes in temperature over time and in terms of the anomalies compared to the average over, in this case, they were looking at the period from 1900 to 1960. And so you see globally, we see this very apparent and very obvious increase in temperature that's happening almost everywhere across the globe. And temperatures, when we zoom into the US, they've warmed across most of the country. Now, you do notice that one very notable exception is in our region. In parts of the Southeast, there is this funny anomaly where temperatures in the winter have actually cooled in a few states, and in the summer, and even more widespread cooling in sort of some of the southeast and parts of the south central and the Midwest of the US. There's some reasons for that and some hypotheses. We don't have a really clear understanding, but it's just one of those funny things that it's an anomaly and just happens to be affecting us in our region right now. But we see other measures of climate change as well in terms of this warming. So, for instance, we have more, the ratio of daily record highs to daily record lows has really jumped up in the last few years. And then as we look into the future, we can use climate models to then project if we increase the amount of carbon into the atmosphere at different levels, depending on how much carbon humans continue to emit and put into the atmosphere, the response of the climate system will then vary according to that amount of carbon. So these are different scenarios of related to different scenarios of emissions. So RCP 8.5, RCP stands for Representative Concentration Pathway. This one is the highest scenario that we tend to look at. It also is the one in terms of the amount of emissions that tracks most closely with our current rate of emissions into the atmosphere. And you can see the difference really, that this main separation really occurs after the middle of the century. So then how does that translate other than, say, global average temperature? Well, for instance, here on the left, we're showing projected change in the number of days above 90 degrees Fahrenheit. So this is just by the middle of this century, so in 20, 30 years from now. And you see if we continue on that higher emissions path, we have a pretty large increase in the expected number of very hot days. And conversely, we expect a significant decrease in cold days. The reason, obviously, why the projected decrease in cold days is less in Florida is because they already have a lot fewer days like that. So overall, we would expect, depending on which emissions scenario, which trajectory or pathway we continue on, we would expect more hot days and fewer cold days. Okay, so big change number two is that it rains harder. Why is that? Well, a basic physical, property just of one of the laws of thermodynamics or an outcome of one of the laws of thermodynamics is that a warmer atmosphere will have more water in it. Okay, so this is something called the Clausius-Clapeyron relation, and basically the amount of water vapor in the atmosphere increases as temperature increases at the surface temperatures that we experience. So global warming means that what we call the saturation water vapor amount increases, and that allows the atmosphere to hold or contain more water vapor, which then eventually leads to a downstream effect in the increases in the rainfall rate or the capacity for that water vapor to then rain out. And so you would expect an increase in precipitation globally as the climate warms. And in terms of observations, we are seeing that so far. As we get down to finer and finer scales, you get a lot more variability. So in terms of, say, annual precipitation in the US, while large portions of the US have seen increases of precipitation, you see some areas, notably in the Southwest, where you've seen declines. And that varies even more depending on which season you're looking at. For the Southeast, the fall season has shown in particular a lot of increases in precipitation, again, with the notable exception of Florida, where they're seeing some significant drying. But then where this really shows up in terms of this relationship with a wetter atmosphere or a more energetic in terms of water vapor atmosphere is in precipitation extremes. So we're seeing some really significant increases in 2-day or in extreme events. In this case, we're looking at the 2-day precipitation events exceeding like a 5-year recurrence interval. So you see that the number of extreme events is increasing through time. And those observations bear out when you look across the US, almost everywhere except in the Southwest US. When we project into the future, again, looking at the annual precipitation, so just the overall or even just the seasonal precipitation, it's really not clear, except in the high latitude, so like in the boreal regions, it's not clear if we'll end up with wetter or drier total amounts of precipitation when we talk about North America and the US. So in these figures, the red stippling indicates areas where all the climate models are in agreement, and darker green means more precipitation, greater percentage change. Browns mean a decrease in precipitation. The slashes or the hash marks here mean that there isn't really any model agreement. So there's a lot of uncertainty. And you see that uncertainty covers pretty large areas of the US. So we're not sure which way things are going to go in terms of the total amount of precipitation, but we do have a pretty high confidence that extreme precipitation events will become stronger and more frequent. So again, annual or overall precipitation, there's a lot of uncertainty, but we expect fewer showers and more deluges. You can think about that. So more extreme precipitation events. Okay, so then the final big change is that the seas rise. So ocean levels, we expect those to increase as the climate warms. And that's really because of two factors. So melting ice on land and expanding volumes of the ocean. Here we're showing the observed and then projected global changes in sea level rise. This is from the IPCC, Intergovernmental Panel on Climate Change, the 5th assessment report that came out now, I believe 6 years ago now. One thing I wanted to just highlight, and my apologies that the graphic didn't show up here very well, but when we talk about things like sea level rise, you really have to think about the system inertia. And because it takes a long time for something like all the ice on Greenland or all the ice on Antarctica or even large portions of it to melt. It takes a lot of energy to melt ice. And then also there just is so much ice locked up in Greenland and Antarctica that's takes a long time. But once you start that process, it tends to keep going if you give it a big enough kick. And that can then take that sort of melting process, and the effects of that can last for centuries to thousands of years. So this is actually showing, this was an interesting study looking at a 10,000 year projection of changes in sea level rise and for different scenarios of the total amount of carbon that would be emitted into the atmosphere. And you see, like, this is showing on the scale on the left, this is showing zero, that the 0 line change in sea level is here. This is 50 meters of sea level rise. And if you go out to a couple thousand years from now, And we end up emitting basically the entirety of carbon that could be emitted. Now that's potentially, you might think that that's not a realistic scenario, and you have an argument for that. But if, say, we did burn up all the carbon available to us, then you could expect potentially up to 50 meters of sea level rise into the future. So something to think about in terms of the timescales at which some of these changes, they don't just end at the year 2100. A lot of these changes aren't done by the end of the century, and they could continue to have major impacts for many, many future generations. So looking at, again, going back to a shorter time frame and the projected global mean sea level rise, we see that depending on which scenario we end up on, you could have anywhere from 2 to upwards of 8 feet globally of sea level rise by the end of the century. If we look at North America and maybe zoom into the southeast, we see that there's actually pretty strong amounts of relative sea level rise in our region. That's due to some physiographic and some factors that are specific to the region that tend to make sea level rise a bit worse in our area in terms of the rate at which it's happening. And so that means that then, you can get, here's it, for example, at Cape Lookout National Seashore, you can get like stronger overwash events due to storms or more intense wave action. But you can also get in things like just what some people call it sunny day flooding or nuisance flooding. Here's an image showing Charleston, South Carolina, and showing these sort of high tide flood events that are becoming pretty common. If any of you have been to Charleston, it's probably pretty likely you've experienced one of these or just seen some water standing on the road now. And so these sort of recurrent floodings, we expect them to become more frequent in the future. We've already observing that. So this is showing for Norfolk, Virginia, and we're into the 1960s. They expected 2 flood days per year just from these sort of like high tide events. By the 2010s, that had increased to 8 flood days per year, because again, where you're really thinking about is not at the center of the distribution of the high water mark, but really the tails of the distribution or the extremes. And as those extremes change, you can get, like in this case, 4 times as many flood days just from a small shift in that high water mark. So looking forward in the future, this is showing again that same sort of recurrent flooding and the projected changes for a lot of places along the southeast coast and the east coast, in this case, Wilmington, North Carolina. You might expect there isn't much difference between the lower emission scenario and a higher emission scenario because of that really strong inertia in the climate system. Some place like Wilmington, the models right now are projecting pretty consistent recurrent flooding or sort of nuisance flooding events by the end of the century. So then one more just sort of big effect that's pretty specific to our region that I wanted to cover is then hurricanes and what's going on with hurricanes and what do we expect to happen in the future. And there's really 3 critical processes that we have to think about when we're talking about hurricane changes. The first one is just ocean temperatures themselves, So that's you can think of that as the engine or the size of the engine that could drive hurricane strength. So the potential intensity increases as oceans warm. So that's the first one. And here this is showing the multi-climate model mean projection of increases in sea surface temperature by the end of the century. The second one, which actually serves to potentially weaken hurricanes, is wind shear. And so stronger winds, if you have wind shear, just means that you have stronger winds at higher altitudes, excuse me. And if you do that, it can really weaken a storm and sort of break it apart, because you sort of it allows for drier air to get into that storm and really weaken that engine, that cauldron of convection that normally would go on. Our projections show changes in wind shear, where some areas we expect increased wind shear. That's what's showing in the Caribbean here. In the southeast, we might actually see decreased wind shear, which could portend that as storms get closer to the East Coast here, they might actually increase intensity, have more chances to increase in intensity. And then the final process that we have to think about is the humidity in the atmosphere in that column, particularly a bit higher up in the atmosphere. So in general, this is another potentially like good thing in that as the climate warms, it's that same process that allows for a wetter atmosphere actually means it's harder to reach saturation of the atmosphere. We have something called like an upped ante mechanism, where to get like the full amount of water vapor in the atmosphere, it just takes way more water vapor than the atmosphere is able to hold as the climate warms. So globally, we would expect that actually would hinder the development, the initial development of tropical cyclones. But again, there's regional variability in that. And so in some areas, if you actually see increases in humidity, you could see increases in the number of hurricanes or tropical cyclones as well. So those three processes, pretty complicated how they all work together. But the models that have done that work show that the main effect is that the number of intense hurricanes, showing in this case, say number of Category 4 and 5 storms, tends to increase under higher emission scenarios. And so that's really the main effect of that, is more higher number of more powerful hurricanes, but the overall number of hurricanes, we're not quite sure how that's going to shake out. Okay, and then you can see how that affects things such as the amount of precipitation that falls. So we're probably all familiar with, in this case, this is Hurricane Harvey, and the really extreme amounts of precipitation that fell there. There are studies that came out showing that climate change, the anthropogenic or human-caused component of Harvey, likely increased total precipitation amounts by about 38%. And actually, the main way that might have occurred is because climate change might be slowing down the forward speed of tropical cyclones. And so the slower hurricanes go, then the more rain they're going to dump on an area, right? So that's something that could be a pretty significant impact. And obviously things like we saw the devastating impacts of Harvey and Florence just recently in North Carolina with those slow moving storms. And then finally, the intensity of those hurricanes really can rev up. Again, as the climate warms and the ocean warms, that heat potential from the ocean increases, and that means the maximum potential wind speed and the potential intensification rate both increase. This is showing an animation showing satellite imagery of the eye of Michael as just right before it hit the Florida coast. You can see that here. And that rapid intensification where it did get up to a Category 5 storm was probably related to the fact that the ocean temperatures were so warm and it just didn't encounter any wind shear at that time. So what's the final call on hurricanes for our area for the Southeast? Well, it kind of depends on how these three things work together. The ocean warming, the wind shear, which would tend to cause weaken hurricanes, and relative humidity in the atmosphere column, which should also weaken hurricanes as the temperature increases. And so the net effect is still pretty uncertain, although again, overall for strong storms, we expect there should be a greater likelihood in any given year of stronger hurricanes. Okay, so finally here, let's get on to the volume 2 of the National Climate Assessment and the Southeast chapter. So in a nutshell, again, we have these 4 key messages: urban infrastructure, flood risks in low-lying regions, natural ecosystems being transformed, and economic and health risks for rural communities. And so I wanted to just, I'm not going to read these key messages, but just to give you a flavor of what we tried to do differently in this climate assessment, we really tried to use this risk-based framing approach where we highlighted what we valued. In this case, is for a key message, it's the cities that are vulnerable to climate change. And the things about cities that we value, these are, a lot of people moving to the Southeast, so our cities are growing rapidly. But what's at risk? what's at risk these cities. So here we identify where they're at risk due to heat, flooding, and potentially vector-borne diseases brought about by a changing climate. And then we also then talked about what potential opportunities for adaptation there might be. So we tried to do this throughout the chapter and throughout the different key messages that we highlighted. And I just leave these texts up here so you can read them at your leisure. So for key message 1, we highlighted things such as the changes in the number of hot days and warm nights. Hot days have actually decreased through time because we've, again, that anomalous type of pattern we've had in the Southeast, combined with the fact that the 1930s were just an extremely warm period in our region. But the number of warm nights, so here we define that as nights where the minimum temperature is above 75 degrees, that has increased through time. Okay, as we project forward, we expect a lot more very warm nights throughout the region, particularly for the higher emission scenario, but still more warm nights even under a lower emission scenario. That's what this RCP 4.5 means. And that thing could have consequences for other things, such as, in the Southeast, we are starting to be exposed to a lot more of those diseases that are, or those vector-borne diseases that we typically think of as occurring in more tropical regions. So that was something that we're going to have to be thinking about in the future. We've already talked about flood days, so I'm not going to go back over this, but this is, again, something in our region that's really, systemic across the area, that the regional sea level rise on top of the global sea level rise signal in our region is pretty high. And so those more, not just from storm events, but also those recurrent sort of low level flood events, we expect those to increase in the future. Again, as the climate warms, the atmosphere will contain more water vapor. And so when you get the right mix of conditions to have pretty strong storms, those can result in these really extreme precipitation events. So this is this one that occurred in October 2015. Some of you might remember that, where there was just gobs of rain that fell, particularly on South Carolina, where technically you could say this broke the 1,000-year storm record event, although that could be more of a function of we just don't have a very long record of precipitation events. But it just shows how these extreme events, you can have a quote unquote 1,000-year event until you don't anymore. And we're kind of running into that, where these extreme precipitation events are just changing the statistics in terms of how we characterize these extremes. And again, hurricanes, and we just talked about this, and those warm waters contributed to the formation and then the strengthening of Hurricane Irma. We had a little case study on this in the chapter, which I encourage you to read, to show how Irma really, the intensity of it and how it passed through southern Florida and caused a lot of destruction there. So for ecosystem, this is something that we're all probably pretty interested in the Southeast. One really interesting thing we could see along the coast is the types of vegetation communities really changing as the climate warms. So the most iconic example of this is mangrove forests, which are very sensitive to annual minimum temperatures. This is some work done by my colleague, Mike Osland, who is also a co-author on the chapter. And these salt marshes could really start transitioning into mangroves down the line as winter minimum temperatures increase, particularly in places like Florida, which have a bit more moderate climate anyway. But this is something to think about in terms of what the consequences would be for the ecosystems and sort of the assemblage of species that are used to one type of ecosystem and then transitioning to a different type. We also expect changes in things that you might a lot of like the general public is interested in terms of this is showing plant hardiness zones. So what types of plants might be able to survive in different regions. Warm winters favor, again, analogous to those vector-borne diseases, these invasive species that are found more in tropical locations are now finding a more pleasant home further north than they used to. And so the Burmese python, which you're all familiar with, is a really very significant and important example of that. All right, finally, we talked about adaptations, and one that a success story in the Southeast really is the use of prescribed fire. So prescribed fire, we showed here in this figure showing that it really is this strong relationship in terms of reducing the risk of wildfires. This is showing the wildfires for Fort Benning and the number of acres burned or hectares burned for prescribed fire. You see this really strong decrease in wildfire over time. And so using prescribed fire we highlighted as an example of a really important adaptation that's been able to not only reduce the risk of wildfire, but also promote different ecological objectives and other health objectives. So that was one thing we highlighted as a real success story. And so I just wanted to finish up then with one just small interesting example of maybe how this could look going forward. This was not in our chapter, but I wanted to highlight some of the vulnerabilities that you might see in your parks. So we know we have a biodiversity hotspot in the Southeast when it comes to different amphibians. So here's an example where salamander body size is found to change under different climatic conditions. So there might be climate sensitivities to, climate sensitivity for under warming and drying conditions in this case, for salamanders. So what that might look like in the future, if you're thinking about, say, Great Smoky Mountains National Park, where you have a high diversity of salamander species, that you have cool and moist conditions now. This is North Carolina, Smoky Mountains is in here. And what might happen in the future? Well, by mid-century, we expect some warming. By the end of the century, depending on which emission scenario, which trajectory we go on, we might see a lot of warming. With precipitation, though, we're not sure. High uncertainty. It could go drier, it could go wetter. There's a lot more uncertainty about that. So what that means then is that if we end up with a warmer and drier climate, that area of cool, moist conditions would be more like current conditions, say in upstate South Carolina, if we end up with, say, a warmer and drier climate. But if we end up with a warmer and wetter climate, that same location might be more similar to the current climate out in Dare County, North Carolina, close to the ocean. So these are just the types of ways that it's unclear when you get down to the ground level of parks how climatic changes could actually affect species. And so you probably have to account for that different types of uncertainty that could happen into the future and gauge the level of risk that might occur given different types of climatic changes. So that's all I had for now, and thanks for your time, and I'm happy to answer any questions. I think we still have a little bit of time left, so thanks very much.
Okay, thank you so much, Adam. That was so interesting and really well put together. I had several questions going along, and then you resolved each of them as you went through the issue, so it was very, very helpful. We do have an opportunity for questions now. You may click on the raise your hand icon on your webinar taskbar and we can unmute you. Or you may type your question into the questions box and Matt and I can read them aloud. I do have one question here from my colleague, Matt.
Yeah, actually, Melanie and I were discussing this while you were presenting, and we were going back and forth. The wind shear effect on hurricanes are really interesting, especially where you showed, wow, might really knock them down in the Caribbean, but then you showed, wind shear might decrease near the Carolinas. Maybe that's bad news. And we were debating, well, could something go through the level of higher wind shear, and would it re-strengthen for the Carolinas? Are we basically, is it as simple as bad news for Carolinas, good for Caribbean, or I don't know. We were just wondering if you could go into a little bit, because we were talking quite a bit about that.
Yeah, I mean, you kind of summarized it in that it could go, all those are possibilities. And so in terms of the climatology, or sort of the average conditions we would expect to change, you could probably frame it as, and this study just came out, so this is pretty recent research, but that along the South Atlantic coast, there's probably a slightly higher chance of more intense storms in the future, because as wind shear decreases over time, as the climate warms. If you go into not only the Caribbean, but also the Gulf Coast, there's also expected to be an increase in wind shear into the future. So, so while that South Atlantic coast, right now, the best available science is showing an increased potential for more intense hurricanes, because wind shear decreases. You see the opposite effect in the Caribbean and the Gulf Coast.
Excellent. Yeah, thank you for that overview. It does seem like it, like all things with climate, the answer is always it's complicated. So that'll be really fascinating to watch over some of these forthcoming seasons. I think at this point, let's see, we have another question here. I know this might be our last one for now. We do have another Q&A session later after the panel. Adam, will you be able to stick around through the end of the webinar today in case there are more questions that come through for you after the panel discussion?
Sure thing. Yep, absolutely.
Okay, excellent. Yeah, this one was about the nature of rapid evolution observed in the salamanders in response to climate. Is that change adaptive or maladaptive? And do we see examples of other, rapid evolution in southeastern species?
Oh man, I'm going to punt on that because that was not my study. But if there's a salamander expert on, that would be a great question to address.
Okay, so all the salamander experts, please click the raise your hand function on your toolbar.
I'm watching that raise your hand icon, and no one is willing to ask a verbal question over the webinar. I get it, there are 70 people here. It's a little intimidating to put yourself on the spot, but we'll keep our eyes on the raising of the hands and maybe get to some of those later. But I think for now, since we're right on schedule, maybe it makes sense to turn it over to our panelists.
Absolutely, yes. So Adam, thank you again for joining, and thank you for being gracious enough to stay on. Please continue to enter in your questions in the questions box as we move into our next session. This time, I'd like to welcome our invited panel of guests attending today from the Southeast Parks. Let's see, I'm very pleased to introduce Janet Cakir, and she will lead this next session. Janet holds bachelor's and master's degrees in geography from Radford University and Virginia Polytechnic Institute and State University. Her PhD is in Parks, Recreation, and Tourism Management from North Carolina State University. Dr. Cakir has built an academic and professional career focused on the human-environment interface. Her doctoral research applied GIS and GPS technologies to spatially and statistically model hiking trail degradation. Following her academic work, Dr. Cakir focused on ways people were connected to the environment and exposed to air pollution, especially mercury, particulate matter, and ozone. Now she works for the National Park Service, connecting parks with the science of climate change and identifying how climate can change future risks to park resources. Welcome, Janet.
Janet, you're still muted, so you will want to unmute your phone so we can hear you.
Thank you. Thanks, Melanie. I'm really excited to be here today and really looking forward to talking with our panel, Jeff West, Dan Brown, and Barbara Judy. So I'll be asking them some questions about how climate change is affecting their work. We'll learn ways that parks are adapting and ways that the regional office is working with others, including the Climate Change Response Program, to support parks. And so for this part of the webinar, I'll first kind of interview Jeff West. He's the superintendent of Cape Lookout National Seashore. He's worked for the National Park Service since 1983. Although Jeff has worked for interpretation and maintenance, he spent 28 years in visitor and resource protection, where he served as an EMT, SAR technician, boat operator, and law enforcement ranger. He retired from law enforcement as a chief ranger before he moved into the deputy superintendent position at New River Gorge. Jeff has also been heavily involved with incident management over the years, acting as operations section chief for both the Midwest and Eastern incident management teams. So we're lucky to have him now here in the Southeast region as superintendent at Cape Lookout. So Jeff, one of the first things I wanted to ask you about, can you tell us a little bit about the challenges facing Cape Lookout?
Oh, yeah. Yeah, so we're kind of like at the heart of everything that's aimed at the East Coast. So, just besides the day in, day out struggles in the marine environment, we do have a lot of storms here. You never hear about the winter storms that have 60-mile-an-hour winds. And you never hear about the impacts of those things, but it is a difficult environment to work in. It's a difficult environment to preserve things in. Difficult environment to even do really good research sometimes. So makes things interesting.
I bet. What decisions do you feel climate change is pushing you towards as superintendent at Cape Lookout?
Well, oh boy, that's a good question. It's a hard question too. So, you can use science to make decisions and come up with some pretty sound decisions doing that. But science alone isn't what the National Park Service is about. Heavy foundation, but we have cultural resources. We have visitor user groups who have great impact and influence on us, of course. So, one of the things that we've been trying to do is take a look at the science that's out there, apply that to infrastructure, historic resources, cultural resources, natural resources, but also take into account some of that more difficult thing to quantify. So, if you look at individual perceptions of what's important in a park, you look at the financial considerations of what you can and can't actually do out there. I had one suggestion one time, we build a dike around things. Great idea, but there's no way I'm getting the money for it. But you also look at the societal values that people place on the area and the things in it, and you combine that to come up with some decisions that actually can affect, how we're going to manage a resource or an asset, whatever it is, well into the future, or it can help us make a decision that we can no longer take care of that thing, whatever it happens to be.
Well, it sounds like, at a coastal barrier island park like Cape Lookout, there's decisions that need to be made constantly for almost every resource in the park, and that's thousands probably. And on top of that, multiply that by the number of stakeholders who have an interest in each one of those resources that you manage. That's a balancing act with a really strict budget. So how are you able to move forward? I know that's a situation that most of our barrier island parks are in.
Yeah, I need to check the tide. I think we're about 56 miles long right this minute, but we'll get smaller later and bigger later on. So how are we moving forward with that? You have to take each aspect and look at it based on those criteria I mentioned before. Not just the scientific evidence of what's happened in the past and what we can predict to happen, but also the societal and economic views that have to impact what we can or can't do. So, one of the things that we did was look at our historic structures. We've got 69. Well, 69 are still in the LCS. We're down 5 of those since the storm. But which of those structures can we preserve financially? There's a limit to what we can do, how much money there is out there. But beyond that, there's structures that people feel are very important, would like to see us preserved, maybe not in the way we've done it in the past. So, what we've done is a study to look at certain historic structures, for instance, in the park, to see which of those structures are important to people and ask them what management decisions they would like to see us take over the next upcoming years to preserve those things or not preserve them. It's a foreign thing for us. I saw some of those slides come up. Y'all can put those back up if you want to. And it's a foreign thing for me in the National Park Service to say, I've got a historic structure and I'm not going to protect it, or I've got an asset. This is our main harbor near our visitor center where most of our operations take place. Most of our visitors access the park. These pictures were shortly after Hurricane Florence. Not only did we have shoaling in the harbor, our main harbor, but we lost most of the docks. So, if you look at how we do things and how we've always done things, and you say, well, can we do them differently and make them last longer? Can we actually exist in and with the environment as opposed to saying we are here and we will overcome? Those docks, we rebuilt docks out there, but we did not rebuild them using the same materials, for instance. We used flow through on them, which we've used in other parks throughout the country to see if it's going to work. It's an experiment, but I know this. Those same docks have been rebuilt dozens of times over the years. So if we do it the same way we always did it, what are we going to get? The same results. So we're trying something different. And that's kind of the key to this whole living in nature instead of, trying to, impose our will wherever we want to on it.
Now, in that example, did you plan ahead and say, well, this dock is going to be destroyed again eventually? And did you sort of pause and say, well, what would we do differently if we were to rebuild this dock at some point? Or was it something that you had to decide after the dock had been destroyed and you kind of had to say, wait a minute, let's not do this all over again. Let's figure out a way to rebuild this more sustainably. Because
I think one of the problems.
Yeah.
Yeah, I'm with you. I think one of the problems in not thinking ahead, not trying to think about, wow, what happens? Because, we consider everything out here to be a temporary structure. So if you're looking at it that way, it gives you the opportunity to think about it as well, what can we do different to make it less temporary? And Category 5 hurricane comes across here, and there's a lot of things that we think of as, fixed structures aren't going to be here. So what we did was we went around the park and we looked at how we did things in the past and what we've had to do after each storm recovery. And I was amazed at how many times we redid the same thing, not because of any other reason other than expediency of the moment. If you've got to have a dock because you've got to get supplies from point A to point B, then you're just going to put a dock in as quick as you can. And that temporary structure becomes a permanent structure. So this time we thought ahead about what we were going to do. We got different kinds of materials and we brought them in. We knew we were going to do things differently with the dock. So we went with a product called hog slat on some of the larger docks and flow through on these decking on these smaller docks. We've had a lot of success with those in other parks. We've had a lot of success with the hog slat heavy docking here. Our design considerations for major projects, we've looked at different techniques for those too. Trying to look ahead and get ahead of this problem, not doing it just because we've always done it that way.
Right. Oh, that's a great example. There's a chapter in the Coastal Adaptation Strategies Handbook that the Climate Change Response Program developed that describes exactly that process, and that's the recommendation: be prepared to take advantage of disruptive events. So I'm going to go ahead and move on, and we're going to talk a little bit with, thank you so much, Jeff, for telling us about your experiences. I think it's great pictures, great examples for us to learn from. And so I'm going to sort of turn my attention now. We're running short on time, and ask Dan. Introduce you to Dan Brown. Dan has served as superintendent of Gulf Islands National Seashore since 2010. Dan's other assignments with the National Park Service have included serving as park superintendent at Chattahoochee River National Recreation Area and at Kennesaw Mountain National Battlefield, and as a park ranger at Olympic, Death Valley, Great Sand Dunes, and Hawaii Volcanoes National Parks, and at other Park Service areas, including Lake Roosevelt, Black Canyon, and Jean Lafitte. So we are thrilled to have Dan at Gulf Islands National Seashore. And thank you for serving on the panel, Dan. Could you tell me a little bit about the kind of challenges that Gulf Islands is facing?
Well, just like Jeff, we're very sensitive to certain types of weather-related issues, hurricanes in particular. We basically have 2 seasons here, hurricane season and outside of hurricane season. So we tell time here by the storms that have hit us here at Gulf Islands. Our barrier islands, the National Seashore here at Gulf Islands, we do have some mainland units, but the majority of the National Seashore are barrier islands that are very narrow, very low-lying. Much of the islands are between 2 and 6 feet above sea level. So they're not only impacted by routine weather events, but also certainly by storm surge related to hurricane. To give you some sense, during Hurricane Katrina, certainly one of our larger storms, the storm surge in Mississippi there at our barrier islands was about 30 feet high. On Ship Island, we have a Civil War era fort, Fort Massachusetts, the walls of which are 28 feet high, and everything on the island completely disappeared as Hurricane Katrina came through, the storm surge came through. When the water retreated, the fort remained, but every other piece of infrastructure that had been built on Ship Island was gone, and so everything had to be rebuilt. We have similar issues from hurricanes over in Florida District. Again, any kind of major hurricane event will severely damage, if not destroy, our roads, the primary access to our park facilities, and has also significantly damaged or destroyed infrastructure that serves our public. So we're very, very sensitive to those types of things and have had to plan accordingly.
Wow, 30 foot of storm surge during Hurricane Katrina. I didn't know it was that high. That's amazing. And with the access roads being damaged, that must make it even more difficult to respond after storms and things like that. So given that kind of really dynamic environment, what kind of decisions do you feel that climate change and these types of events are pushing you towards?
Well, the year before Katrina, we had a Category 4 storm hit Florida, Hurricane Ivan, and it completely breached the west end of the island. We had open water flowing between Pensacola Bay and the Gulf of Mexico. The breach did eventually heal, unlike the breach of Fire Island during Superstorm Sandy. But it did really raise the question about the ability to maintain road access, vehicle access to the single most heavily visited area of the park, Fort Pickens, which can have upwards of 1 million visitors just at that one site in the park. They did go ahead after the natural sand transport system moved enough sand to heal the breach. They did rebuild the Fort Pickens Road. When they did that, they were almost done with the road. They had only this restriping left to do, and the following year in 2005, another Category 4 storm came, Hurricane Dennis, and destroyed the road yet again. So that time there was a pause of about 4 years where we went through a planning process to decide what to do. Do we rebuild the road, and if so, how does it get rebuilt? And they did go ahead and agree to spend yet a second $12 million in back-to-back road reconstruction, almost $24 million. But this time they lowered the elevation of the road. We find that with that storm surge, it carries and deposits an awful lot of sand. And in areas where the road is at a low enough elevation, it buries the road in sand. And all you have to do is remove the sand, which is in and of itself a heroic task because it'll be buried sometimes 4 to 6 feet deep. But then the asphalt has been left intact. Some of the other things we've done, there were portions of the Fort Pickens Road that were as little as 15 feet away from the Gulf of Mexico. And when we had a regularly scheduled asphalt overlay project, it seemed to make no sense to me to spend the money to put more asphalt on a section of road that we were probably going to lose to the Gulf. So we asked Federal Highways if they would rescope the project and allow us to realign that section of road and move it further away from the Gulf of Mexico north towards Pensacola Bay. And they agreed to do that, gave us some additional funding, and we realigned about 1.7 miles of the road. and also tried something else new. In the past, they had used road-based materials underneath these roads, but with so much road destruction, not only was the asphalt broken up and scattered, but so was the road-based material, the gravel and such. So this time when they rebuilt the road, they put no base. In places, they put the asphalt directly on the loose, unconfined sand, but they tried something new in that realigned section. They used a geofabric, and on top of that, put some grid material, kind of a honeycomb-like material that they then filled with sand so that the geogrid would contain that sand, and then they laid the asphalt on that. So we've had a few minor storms since then, and it seems to be holding up a little bit better. So some redesign, and we've had to look at redesign of a lot of our other facilities as well.
Wow. That seems so counterintuitive to sink a road lower that as being impacted by storm surge, or to, stop putting an underlayment material, so it must have taken some real serious planning and looking at designs and things like that. How did you find the time, and what helped you to move forward to come up with those adaptations?
Well, as we went through the NEPA process, there was a tremendous amount of civic engagement, and it's amazing. The American public love their vehicles. They want to be able to drive everywhere, and so they looked at a whole range of alternatives and did come up with initially preferred alternative that was a no build, and were asked to go back to the table and come up with a build option. So that's how they arrived at that particular strategy. We do have another road segment on Santa Rosa Island in Florida, Highway 399, that is between two communities out on the island, between Pensacola Beach and Navarre Beach communities, and the park lies in between that. And those communities are reached by two separate bridges, which are at risk during major hurricanes and storm surge. And if one of those bridges were to go out, that particular road connecting the two communities, that road through the park, becomes the only avenue of escape for those people from the other community. They have to go through the park on that road to get to the other bridge. So we're going to try our best to maintain that road as a hurricane evacuation route, and again by redesigning, lowering the elevation to help protect the asphalt. One of the things that before they allowed the road to get rebuilt a second time out to Fort Pickens, the park was advised it was time to start getting very serious about providing a ferry service out to the island. And so we started working very hard on that, and over the past about 7 years or so, been able to finally sign a 10-year contract for ferry service from the mainland in city of Pensacola out to Santa Rosa Island, two different locations, community of Pensacola Beach and also out to Fort Pickens. So we now have ferry service so that if the road does go out, our general management plan says we'll do what we can in terms of what's feasible, but at some point the island may get breached again. That breach may be permanent, and the only access then will be boat access.
Well, nice redundancy in systems there too. So thank you so much for sharing with us your experiences there as superintendent. I know you'll probably get a lot of follow-up questions. We can all learn from your example and from Jeff's. Let's take a look now at what role the regional office is playing to help and support our parks as they adapt. As part of our panel, we have Barbara Judy. Barbara is the branch chief of Cultural Resources Planning and Stewardship at the National Park Service Southeast Regional Office, where she has oversight and responsibility for the region's historical and landscape architects. She previously served in the region as superintendent at Jimmy Carter National Historic Site. Barbara Judy joined the National Park Service in 2000 as a historical architect at Golden Gate National Park in San Francisco. In 2006, she moved to Gateway National Recreation Area in New York metropolitan area, where she worked as a cultural resource specialist and chief of project management. So 3 years later, she became chief of resources at Bandelier National Monument in New Mexico. Prior to joining the National Park Service, Barbara was an architect in private practice for 20 years with a focus on rehabilitation of historic buildings. So thank you, Barbara, for joining us today. Can you tell us a little bit about how the Cultural Resources Division in the Atlanta Regional Office is responding to the threat of climate change to park resources?
Yes. Okay, so what we do, my group comprises the historical architects and historical landscape architects that support all the Southeast region parks. And our concern right now is to get ourselves to a level of education, information, and conversance with climate change effects and emerging adaptation scenarios, so that when our park colleagues come to us and they have a novel proposal, you know, Superintendent West made mention of, for example, approaching decisions to not maintain certain cultural resources, that sort of thing. What we're trying to do is to catch up with the thinking that's happening at the park. And so just to add a little bit of detail to that focus, we've been in conversation with our technical services colleagues in the Washington office to try to gain insight into their thinking as they develop new standards for dealing with resilience to natural hazards. And they've shared with us their work plans for the coming couple of years, including a preservation brief on adaptation, further development of the treatment standards to address managing buildings in flood-prone areas. And they're also working on a cultural resources training on adaptation. So our hope is to be good ambassadors for their program. We also worked with you, Janet, to make sure that we were aware of the kind of data that has been developed on climate change conditions. And so that data is grouped into two broad categories. One is retrospective data, looking backward, what has happened. And the other is prospective data, looking forward, what should we expect to happen under these different emission scenarios. And we've got conversant with the tools that you all are using in order to graphically convey that information. We also worked with you to go through the optimization models that are happening at Gulf Islands and Cape Lookout. That's a tool that's underway right now that's helping the park think about the choices that they need to make going forward. And again, our purpose is to try to meet our park colleagues halfway. So we need to understand the kind of thinking that they're going through. We also have gone through some readers on what's happening to coastal water and sewer infrastructure. So, we're trying to understand the systems that support structures and landscapes staying in place in our national parks, because that's, I think that there's probably, this is an area that's probably underemphasized and really does require some attention. We've also gone through a kind of a selective history of structural moving in the United States. So we're trying to say, we know that people will come to us with proposals for structural moves, and what we want is to kind of loosen up our thinking. So we know that structural moving has a history, and we're asking ourselves to become familiar with that history and try to find parallels in circumstances that are happening today. And then finally, there's just been this business of going to conferences, in this case, the Keeping History Above Water conference that happened in May in St. Augustine, where the intent was to just be part of a larger conversation among cultural resource management professionals regarding what is happening with emerging adaptation strategies. So that's the challenge that we've set ourselves. And again, the whole point is to be ready to meet our park partners halfway as they figure out what their questions are going forward.
Well, that's a lot of preparation. How do you think that climate change response will alter the way your division works?
I think it's a combination of a new workload, new knowledge, and new challenges. So new workload, I think an easy example, which I'm thinking that both our superintendents are experiencing, is the hurricane recovery for Harvey, Irma, Maria. And what that's doing is essentially doubling the project level workload at the parks that are affected. And that backs up to us because we support those parks. And then new knowledge, we are seeking new knowledge regarding adaptation scenarios, just as everybody is who is interested in this topic. And then new challenges, an example would be improved readiness for hurricane season emergency response, so that people in this program in the regional office can support appropriately the field recovery efforts as the hurricane season comes through.
Okay. Where do you think the community of practitioners is as a whole?
So as far as we can tell, the cultural resource management community is very focused on the educational burden of conveying the reality and the immediacy of climate change and how it's going to affect particularly coastal areas in the Southeast.
Mm-hmm.
And it's a question of what's happening to communities, what's happening to organizations, what's happening to people, what's happening to the built environment. And, that is, rather than focusing on adaptation scenarios, I think that there is some emerging discussion of adaptation scenarios that is getting a little bit more specific, but still the feeling of others in our group is that the focus is overwhelmingly on we're still trying to carry this educational burden.
Yeah, that's been my observation as well, and that's one of the reasons I'm so proud to work here at the National Park Service is we really are leading in adaptation and understanding how climate change affects our parks. Well, thank you, Barbara. I really appreciate your perspective and insights. And of course, everyone, the regional office is here to help parks, to serve parks. And Barbara is a great contact if you have any kind of cultural resource or historic resource issue that requires technical assistance. I myself am also here to help parks in any kind of climate change, anything that you think might be affected by climate change. Please contact me. I'm happy to help. I think I'm also a part of the panel, and I'm going to be very, very short because I wanted to have these longer conversations with Barbara and Dan and Jeff. But I wanted to take a moment in wrapping up to just tell you a little bit about myself and what I see happening with climate change. Some of the impacts that you've heard about today are from our coastal parks. A lot of the things they're facing are increases in algae blooms, storm surge, sea level rise, of course, saltwater intrusion, threatening coastal trees in the interior. Some of our interior parks, our Piedmont parks and mountain parks are seeing increases in tree pests. They're seeing increases in ozone air pollution formation that's leading to foliar damage of the leaves of trees and shrubs. In the Caribbean, and I think we're going to have another webinar just specifically about the Caribbean, but I wanted to let you know, since they're part of our region, there have been increases in coral bleaching. And, recognizing all of these issues that our parks were facing, in 2016, we developed a regional climate change response strategy and action plan. And this was really something that the Climate Change Response Program at WASO asked us to do, and I'm really grateful for. We went through a process to identify how, as a region, we and our parks could move forward in responding to climate change. And a part of that plan included in developing our workforce informed about climate change. And so I want to thank the Climate Change Response Program for hosting this webinar and helping us to fulfill that goal. Our parks every day inspire our visitors to action to address climate change. Most of our parks interpret climate change. That's a goal in our plan. We also have a sustainability program that collaborates with the Washington office to do green parks plans. And as a part of our goal is improving our Southeast region's environmental sustainability. And finally, we have as a goal managing our resources in light of expected change. So you've heard about some of the projects that we have underway. Things that are coming up, we're working with the Skahutic Institute to bring to the region climate smart adaptation training. Another project we have underway is we're working with WASO and the Sustainable Operations branch. They've reached out to us to offer a partnership from the National Renewable Energy Laboratory to plan for energy resilience in coastal parks. we're working with our facilities folks to get that underway. We also, and as a primary part of my job, or a big part of my job, is to work with partners like the Landscape Conservation Cooperative to plan for natural and cultural resource conservation. In my role, I work to support all of these efforts that we've been talking about today and ensure that parks in the Southeast region are able to take advantage of opportunities like the service-wide comprehensive call to get their climate change research needs met. I also communicate regional climate change associated problems to others so that we can say that our partners know what issues our parks are facing regarding climate change. So in order to do that, I often visit parks. I'll join a staff meeting at a park and provide an overview of how the park is exposed to climate change. And as a part of that, I will often get out in the park and listen to what issues the park's facing. And often the park recognizes that climate change is playing a role in those issues, or that might be something that I could bring to the discussion. So if I haven't been to your park, or it's been a while since we talked, just send me an email and we'll try to schedule something. Another part of my job is to know how parks are adapting. So let's say you've got an issue that you've already adapted to and want to communicate that. I often go to meetings with other agencies and can communicate some of the successes that we're having. So I love to hear about that as well. And finally, I think a big part of my work is interfacing between the Washington office and the region and the parks, and trying to make sure that we're all working together to adapt to climate change, and that our parks are able to take care of opportunities. So thank you, Melanie, for giving us this time to have this panel. I really appreciate it, and for facilitating this call and putting it all together. It's been a great experience.
Absolutely. Thank you, Janet, and thank you so much to our panelists. You're sharing such a robust range of experiences grappling with these issues in coastal Southeast parks. We very much appreciate your leadership. We have another opportunity for questions for Dan, for Jeff, Barbara, Janet, and Adam. So please feel free to raise your hand on the control panel or submit your questions in the questions box. I'm going to read a couple of comments while you have the time to do that. First, Adam, exceptionally well articulated presentation. The topics are so complex and you conveyed both the complexity and the bottom line conclusions. Excellent visualization of the historic CO2 levels. Thank you. The second comment is in reference to our question about salamanders. Kelly says there are other studies that discuss the mobility of both plant and animal species that speak to their adaptability of species to changing environments based on how far they can physically move in a year for plants based on seed spread. These studies would speak to some of the questions concerning salamanders. Thank you, Kelly, for your comment. Matt, do we have other questions?
I do, yeah. There's a couple things that have come in, and I'm going to ask our panelists, I'm going to try to turn on your webcams just so we can see your faces during this part here. The question was, can any of our panelists share like a communication success story where maybe the public made the leap to understand why types or amounts of access might change in light of future conditions, such as, giving things up for future consequences? Anything in your parks or someone you've interacted with where you're like, yes, that was a great leap the public just made there?
I guess I can share a little bit about when the park completed our GMP, and the greatest interest from the public was about what the future of the Fort Pickens Road was going to be. And as we began the planning process to develop infrastructure for our ferry service, and I appeared before the DAB, I will always remember an associate director wagging his finger at me, telling me it was my job to communicate with the community the eventuality of not having a road out to Fort Pickens. And so we've been doing that through our programming, through media, television and radio, at every single opportunity. And I think we've been partially successful from the feedback that we've gotten. We've maybe won over about half of the local populace. The other half, I think, are pretty entrenched. They want to continue to drive no matter what. And so we'll see what nature does. Ultimately, nature could have the final call. If there's no land to build a road, there'll be no road. So.
This is Barbara, and I'm just going to share a really finely scaled issue. When we do a treatment document, a historic structure report, or a cultural landscape report these days, we require that in the treatment section, the contractor address climate change. And what's been interesting for me, and really, and maybe even a little bit funny, is that we find ourselves, when we're working with these contractors, these are people who are part of the cultural resource management community on the private sector side. But we find that they really haven't thought about this at all. And so, our efforts to educate them, to explain the kinds of issues that we want them to address in the treatment section and to collect specifically under the title of Resilience to Natural Hazards and Climate Change. For them, it is really eye-opening. They are members of the preservation community, but the penny is dropping for them for the first time that this is something that is going to become part of our body of practice as professionals.
We've had similar things out here that are quite surprising. As our historic districts become no longer viable, the water covers them, which actually happens today on king tide environments. I threw out to a partner group one day, well, I guess we can't use them as a historic district anymore. We'll sell them. And everybody in there was going, yeah, that's what we do out here. We reuse them. Hurricane comes in, something like that happens, we just move them over to Ocracoke or move them down to Atlantic. And I was quite surprised to hear that kind of thing from the community. And when I brought it up with some of our folks in the MPS, it was like, what? What are you considering? You can't do that. So it was quite an interesting reaction. I almost expected it to be the other way around. Never know what you're going to get.
Thanks, Forrest. I want to try, we have some other questions that have come in that I'm worried we won't have enough time for, but I noticed there's a hand raise that's been up for a little while. Melissa, you're out there, you used the hand raised icon. I don't know if you had a question or not, but I'm going to go ahead and unmute you. And if you do have your question, you can ask that verbally. And if you don't have a question and you raise your hand by accident, well, just say so too. But I'm going to go ahead and unmute you. You can ask your question if you have so.
Okay, thank you. First, thank everybody for this presentation. It was very informative, and it's really good to hear from my colleagues as well. But I guess I had a question about scale. And it seems like a lot of the policy direction from Washington and the regional office is coming back towards parks. And certainly here, I think, as well as Dan and Jeff, I work at Fort Pulaski, we're not just threatened by climate change. We're living through it right now and having to come up with creative solutions just with our recovery. But ultimately, it seems like parks that have to do some sort of capital investment strategy, there needs to be sort of a broader conversation about what parks and further what communities that surround parks are going to be, I guess, the most viable, moving forward with some of these challenges. And I'm just wondering what kind of conversations are happening at the regional level to really, identify what resources are going to be and what parks are going to be really able to adapt.
Thank you, Melissa. I'm going to ask just one person to offer an answer to this question because we need to get moving ahead here.
Sure. I'll take this question. So I think we have a few policies that are out. The Cultural Resources and Climate Change Policy that says to prioritize the most significant and most vulnerable resources we have. We've got, policies concerning natural resources that are pretty much in line with the way that we've done things, use science, science-based management. But we have done some things at the WASO level, like we analyzed the total replacement value of resources that are within 1 meter of sea level rise. And I think that the amount was somewhere around 40 billion, and 95% of that was in the Southeast region. And so that's something that I try to point out when it seems appropriate. At this time, I don't think that there are any huge changes in the way that we allocate funding, and I think that really would be what would have to happen in order to have some kind of different changes in emphasis in how we adapt to parks. Because really, adaptation takes funding. I think right now, adaptation is happening at the park level, and with disruptive events like hurricanes and things like that, when we get funding from Congress, it's never enough to put everything back the way that it was. The more that the individual park knows what they want, how they want to do things differently, the better the chances are that when you do restore, you restore in an adaptive way. As far as ecosystems are concerned, we're trying to manage them. You can either manage them resistively, resisting change, or you can facilitate change. And I think that has to be a decision that's on an individual basis, made in the park. And what we do in the regional office and the Washington office through the Climate Change Response Program is try to support all of those park-based decisions with science, with planning methods, and with technical assistance. And so please don't hesitate to reach out to us. But that's my read on the state of things.
Okay, thank you, Janet. We have unfortunately reached the end of our time today. If you'd like to continue the discussion, and we have several questions that we weren't able to answer, we invite you to follow up with our presenters and our panelists. They've graciously agreed to share their contact information and are willing to follow up on any additional questions. We would like to extend our sincere gratitude and appreciation to our presenters and panelists, as well as those who have worked behind the scenes to bring you this broadcast. As soon as we end this broadcast, a pop-up will appear requesting your response on a very brief survey. Please do take a moment to fill it out. Your responses help improve each of these offerings going forward. In the days ahead, you can also expect to receive a follow-up email with links to the recorded webinar, contact information for all of our presenters, and a few other goodies to share. Thank you all very much for joining us for today's roundtable. As a reminder, we will be holding additional roundtables for each of the remaining NCA4 regions, and we invite you to join those discussions as well. Recordings of past events and a full schedule of upcoming roundtables can be found using the link we are posting in the chat box again now. Have a great day.
Thanks, everyone.